Reminder. Appreciate the reminder. So just doubling back for the recording. This is our imaginary unit. The square root of -1 is equal to I for imaginary. Because the square root of 25, when you look at the square root of anything, you're asking yourself what times itself twice will give you the number that's under the radical. And that's why the square root of 25 is 5. 5 times 5 give you that 25. So the square root of 81 is 8. I mean, it's the square root of 81 is 8. Square root of 81 is 9. The square root of 121 is 11. So if we were to put a negative under the radical, we could break it up into the square root of 25 and the square root of -1. Square root of 25 is 5, but the square root of -1 is this imaginary I. And all of our square roots of negatives can be broken down that way. So that means the square root of -81 will be 9I. Square root of -121 is 11I. Also, don't forget, I think, not sure if we talked about it in this class or not, but just don't forget that even if you cannot take the square root of something evenly, you still are expected to simplify as much as possible, if possible. So let's say if I had the square root of 18, we cannot take the square root of 18 evenly, but I can take the square root of one of the factors. So I can break it up into 9 times 2, take the square root of the 9, leave the 2 under the radical. That would be 3 square root of 2. Remember, you could break up 18 into 6 times 3 as well, but just remember you cannot take the square root of the 6 or the 3 evenly, so that wouldn't help. So you want to make sure you break up your factors into numbers. Break up your number into factors that will help you to be able to take the square root of evenly. So if I had the square root, let's say, of -24. So what I would do is break it up into -4 times 6. I can take the square root of 4. I cannot take the square root of 6. Square root of -4 is 2I. And you leave the 6 under the radical. Another way of writing this, and you just have to be careful when you're inputting it, is 2 square root of I, or 2 square root of 6I. Just putting the whole number of 2 times square root of 6 before the I. And you just have to make sure that you don't extend this radical over the I, because that is incorrect. And my math lab will mark that wrong as well. So make sure it's 2 square root of 6, and then the I is on the outside of that. Questions on anything I've said so far?
Yeah, I didn't really catch the breaking it up part.
Which number are you talking about?
The last example you just showed with
Okay.
-24.
Okay. So whatever you break up, whatever you break the number up into, just remember that the numbers that you use, at least one of them has to be able to be taken the square root of evenly. So that's why I use the square root of 4. Same thing as if I had the square root of 500. I would break that up into the square root of 100 times the square root of 5. And square root of 100 is 10. 5 is under the radical. So I can take the square root of 100. That's why I chose that. Now I also, let's say if I didn't see 100, let me erase this. Let's say if I had, oops. Say if I did 25 times 20. Nope. 4, that was wrong. Where my button at? Okay, I'm good to go. All right, so let's say if I decided to go this route and I didn't see the 100, and I'm talking about for the same breakdown of square root of 500. So if I take the square root of 25, I would have 5 here, square root of 20. but it would be on me to still recognize that that 20 can be broken down even more. So you don't have to, get the largest one every single time. It just makes things easier. So it'll be 5, and I can break down the 20 into square root of 4 times the square root of 5. So then that'll be 5 times 2 times the square root of 5, which brings me back to the final answer of the square root of, 10 square root of 5. So either way, I should get 10 square root of 5. If I do it in pieces, or if I find the greatest factor that can be taken the square root of, that's fine. Just that I have to make sure I keep evaluating what's under the radical until I know that what's under the radical cannot be broken down any further.
Okay,
So,
I got.
yes. I'm sorry, did that answer your question? I think I talked over you. I'm sorry.
Oh yeah, it answered my question.
Okay, great, great, great. All right. So taking it the next step, we're looking at complex numbers. Let's see, chat. Can Mr. Heck, are you asking me, can you record it? Or were you just responding because I hadn't recorded?
Yeah, just that was before, my bad. I just
Okay.
wanted to record it. That's
Okay,
all.
yeah. So if I ever forget,
I learned. I have to go back through all this.
okay, yeah, no problem. If I ever forget to record, that's for everybody, anybody. Please feel free to remind me. Sometimes I get rolling and I forget to press the record button.
All right, thanks, sir.
Yeah, no problem. And also I put complex, complex. All right, so complex number is going to be made up of two parts, your real part and your imaginary part. All right, so here we have a few examples of just complex numbers and how they would look. So 2 plus 5i is a complex number. You have a real part of 2, imaginary of 5. Negative 1 plus 3i, 7 minus 10i. 8, the actual number 8 can be written as a complex number. You could write it as 8 plus 0i. And negative 12i, if you decide to write that, well, that's complex because you have the imaginary part, but that's 0 plus, not plus, excuse me, minus 12i. So the real part is 0. All right, so we are adding or subtracting complex numbers. All we would be doing is combining like terms. So 5 plus 7, let's stay red, is 12. And then negative 11i Positive 4i is negative 7i. All right, negative 5 plus I minus the quantity of negative 11 minus 6i. So just like before, when dealing with regular algebraic terms, you would distribute your negative first. Negative 5 plus I, and it would be minus plus 11i, plus 11 plus 6i. So both of those signs will change. So it's negative 5 plus I plus 11 plus 6i. From there, combine your like terms. Negative 5 plus 11, 6. 1i, 6i, 7i. All right. Multiplying complex numbers. So here we have 4i times the quantity of 3 minus 5i. So you would distribute same way you would multiplying your monomial times a binomial. So that would be 12i minus 20i squared. I times I is I squared. All right. So first thing we recognize once we've done our distribution is that we have an I squared. I squared is the same thing as negative 1, because, well, let me write it like this. Don't forget I is equal to the square root of negative 1. So that means I squared is going to be square root of negative 1 squared. That means the square and square root will cancel, leave me with just negative 1. So, of course, you don't have to go through all of that. I just want to make sure we see why it happens. So negative 1 is equal to I squared. So you should never have negative 1. I mean, a negative 1. You should never have I squared as a part of your final answer because it can simplify to negative 1. So whenever you see I squared come up, you should reduce it down further. I squared is equal to negative 1. All right, so that negative that's in front of 20 sticks with 20. So that's negative 20 times negative 1, which is a positive 20. Also, the other part of this is standard form. Standard form is A plus BI. In other words, real part is written first. So they're going to look for you to write it in standard form. Real part will be written first, imaginary part written second. So your final answer would be 20 plus 12i. And that's in anytime you represent or have to write down your complex number, even whether it's addition, subtraction, multiplication, or division. Once you submit your answer, or when you submit your answer should be in standard form. Real part first, then your imaginary part. And always remember your imaginary part is connected to that I. All right, so here we have 7 minus 3i times negative 2 minus 5i. So we do a binomial distribution or FOIL, whichever way you like to look at it. We're going to take each term that's in our first parentheses and multiply to each term in the second parentheses. 7 times negative 2 is negative 14. 7 times negative 5 is negative 35i. Negative 3i times negative 6 is positive 6i. Negative 3i times negative 5i is positive 15i squared. All right. Problems with the distribution. All right. So now we're going to combine our like terms and simplify. In the middle, we have negative 35i and positive 6i. So it's negative 14 minus 29i. Then we also have I squared. So it'll be plus 15 times negative 1. So now that's a negative 14 and a negative 15 that we have as like terms. So that'll be a negative 29 minus 29i. Any questions? Any questions? All right. Before we go to division, I want to mention complex conjugate. So your complex conjugate of your complex number is just changing the sign of the imaginary part. And each one of them, and I got the arrow going back and forth because each one of them are complex conjugates of the other. So if I have 5 plus 3i, the complex conjugate would be 5 minus 3i. All you're doing is changing the sign of your imaginary part. So negative 8 minus 11i, complex conjugate, negative 8 plus 11i. And if I have 23i, complex conjugate is negative 23. All right, so this one it says divide the complex number. And then I think it says express the standard form, but we're gonna stick with that anyway. It says 3i over 4 plus I. So in order to divide, we are going to multiply. All right, so we're gonna multiply the top and bottom, both numerator and denominator, by the complex conjugate of the denominator. So we're gonna multiply top and bottom by 4 minus I. All right. Write it like this. All right, so multiply numerator by 4 minus I, distribute your two terms, distribute to your two terms, and that'll be 12I minus 3I squared. Once again, I squared is -1. Let's go positive. And standard form, that'll be 3 plus 12I. I'm trying to ignore, man. I'm trying to ignore. So our numerator is 3 plus 12I. So denominator, that's 4 plus I, 4 minus I. And she just threw something downstairs. So that's 4 times 4 gives that 16. 4 times -I, -4I. I times 4, 4I. Negative I times positive I times negative I is negative I squared. All right, so this is why we multiply top and bottom by the conjugate. What we do not want is an I in our denominator. And notice that that cancels out right there. It gives me 16, and then this goes to negative. So that's 16 plus 1, because negative turns positive, and that gives me 17 in my denominator. So, and the reason why we don't want a negative in the denominator, not negative, but I, don't forget I is the square root of a -1. And normally if you're gonna have a fraction, we don't leave radicals in our denominator. Normally we can rationalize our denominator. So this is just another way of doing so. So that's why you multiply both top and bottom by the complex conjugate, so that our imaginary piece will cancel for us. And then to finish this off, that would be 3 over 17 plus 12 over 17I. They will expect you to separate the two. they will expect you to separate the two. That's 17 going to each term. How much does the test weigh? Um, well, I will say this before we go there. It may seem like a lot because I am pausing and breaking and stuff. And then some steps I'm writing out, you may not write out. I'm writing down every single step to try to make sure that everybody's with me. You may not even write down every single step depending on what you're doing and how you're doing it. And then the more comfortable you get with it, the less it will be a process and it'll just be something that you're doing. So I would like to encourage repetition because a lot of times when it comes to math, in order for you to get it, you are gonna have to put that repetition in. One thing I like to explain, I like to use football as an example to help explain math. You do football so much that you're not thinking about it, that you're actually just doing it. You don't want to go on a football field thinking about what your next move. You want to be reacting. And so that's what math really is supposed to do. You're working on math is supposed to do for you. You're supposed to do enough of math so that when you see symbols, you're actually reacting to them and not thinking about what you have to do every single time. There's nothing wrong with thinking about them sometimes, of course, but every single time you don't want to be thinking hard about it. So if I have 3x plus 7 equal to 11, I know most of you are comfortable with this, the first thing you want to do to solve is to subtract 7. But if I put a parentheses right here, the first thing I would do is not subtract 7, but distribute 3. And so you're going to be responding to the symbols that are placed before you. So the more you do this, the less it becomes a tedious and long drawn out process. It's just about you guys getting comfortable with the process. And that's only going to come through repetition. Now, as far as your test is concerned, there was only one, if we looked at what we just did, we did adding, subtracting, multiplying, and then dividing. There was only one dividing that took this type of process, one out of the 4 operations. So even if I had 1 or 2 up there on the test, it wouldn't be anything that would stop you from getting an A. You just have to make sure that, you tighten up on the other things and make sure you get the other things correct as well. Yeah, so that's what I would look to do. There'll only be a few of them, at the most 2 of these on a test. So I mean, I can't make the whole test dividing complex numbers, because there are other things for us to take care of. So, but yeah, so it's all about getting the repetition in though. So going back there to getting the repetition in. There's one more thing I want to emphasize in this section before I look to see if you guys wanted me to do something else outside of the lecture. If you want me to review a certain type of problem, you can do that as well. And let me see how I want to write it. I'll just do it this way. We've already talked about it, but we are re-emphasizing it here. All right, why did I put a 5? So before you simplify or calculate, the emphasis here is for you to take the I out first. And I'll show you why. All right, so let's say if I had the square root of 25, the square root of negative 25 times the square root of negative 4. If I did not take the I out first and just calculate it or multiply it, square root of negative 25 times the square root of negative 4 would be the square root of positive 100, right? Negative to a negative turns positive. Square root of 100 would be 10. And so this would actually be incorrect. So first thing we need to do is to bring the I out. Let's say if I didn't simplify with the radical, I just took the I out, because some situations we will have a radical still involved. And then multiply. That would be I squared, square root of 100. And we already mentioned plenty of times before that this I squared is -1. And then that 100, square root of 100 is 10. So this would be the correct answer. So there will be the difference in you getting a negative sometimes versus not getting a negative at all. So you always want to take the I out first before you do any calculations. And of course, the other way of doing this type of problem, because I could take the square root of 5 and 4 evenly, I could have had 5i times 2i, which would have been 10i squared. And then I would have still gotten my -10. So either way, you still should get -10. All right, questions on that before we do some more? All right. Directions here would just be simplify. So we have the square root of -18 minus the square root of -8. And we need to simplify the square root of -18 and the square root of -8 as much as possible before we can even think to subtract. So when you're talking about subtracting, you have to have like terms. And what's sitting in front of the radical, your index, has to be the same. And what's under the radicand, has to be the same. So in other words, making sure we're okay with that. Square root of 2, let's go 3. Square root of 2 plus 5 square root of 2. I didn't give myself enough room. Just bring it over here. I'll rewrite the other one. So 5 square root of 2 plus 3 square root of 2 would be 8 square root of 2. So what I cannot do, I wouldn't be able to add 5 square root of 2 plus 3 square root of 7. So can't simplify that because what's under the radicand aren't the same. If I had 5 square root of 2 and 3 cube root of 2, can't add that because the indexes of the radicals are different. So if the indexes of the radical are different, or what's under the radicand are different, I would not be able to add them. Or if I had 5 square root of 2 plus 3i square root of 2, I can't combine those because one is real and one is imaginary. At the most, what I could do here is, I don't know if I even would want to do that. Nah, I wouldn't even want to do that. So yeah, that's it. That's all you can do with it. Questions on what you can simplify and what you cannot simplify. All right. So I need to see what I can do with the square root of -18. Can break that up into the square root of -9 times the square root of 2. So that would be 3i square root of 2. Square root of -8, I can break that up into -4 and 2. So that'd be 2i square root of 2. So what we have now is 3i square root of 2 minus 2i square root of 2. And to finish it off, 3i minus 2i is 1i square root of 2. And then, like I said, also it could be written as the square root of 2i. All right, questions on that one? All right, let's do another one. So here we have -1 plus square root of -5. That would be -1 plus I square root of 5. And I forgot to mention the square. But once again, we want to take that I out first because of that negative, square root of negative. So whenever you're squaring a quantity or raising it to any power, you're writing that quantity multiple times to that power. So it's not just squaring -1 and then squaring I square root of 5. You're squaring the quantity of -1 plus I square root of 5. And then times -1 plus I square root of 5. From here, we do our distribution. +1. -1 times I square root of 5 will be -I square root of 5. Next result, -I square root of 5. And then make sure you're careful here. That is I squared square root of 25. So I times I, which gives you I squared, then the square root of 5 times the square root of 5. You multiply what's under the radicals. 5 times 5 give you that 25. Combine your like terms and simplify. So that's 1 minus 2 I squared root of 5. The -1 sitting in front of that I. And then here we can reduce that. I squared is -1. Square root of 5, square root of 25 is 5. Finish it off by doing 1 minus 5, which is -4. All right, got one more to show you out of this section. All right, so we got -25 plus square root of -50 over 15. All right, so first thing we do is look at simplifying that square root of -50. I'll break that up into 25, -25 times 2. -25 is 5i. Square root of -25 is 5i. Leave the 2 under the radical. So now we have negative 25 plus 5i square root of 2. Take 15, apply it to each numerator. And now reduce accordingly. So 5 can divide into each. So that would be 5/3. Well, I'm gonna get negative 5/3. 5 can go into each. And this next one as well. And that'll be it. All right. Any questions, concerns? Anybody want me to re-explain anything? Saw anything they wanted me to do another problem of? That is it for 1.4. All right. Okay. So I'm just gonna initiate 1.5. Not even gonna try to finish it, but I just want to get it started since we have a few minutes. And don't forget, Monday is Labor Day, what I've been told. So we should have off Monday. So I won't see you guys for another week. So like I said, I'll just go ahead and get started with 1.5 just to introduce what we're going to be doing in it. So 1.5 quadratic. That's okay. All right, so our quadratic equations. Our general form of our quadratic equation will be ax squared plus bx plus c equal to 0. We should be getting two solutions here because of the second degree polynomial. That second degree polynomial just means it's the highest exponent of your variable is 2. And normally the highest exponent of a variable will let you know how many solutions you're supposed to receive. Even if you have any repeated solutions, still the most that you should receive is that number. So just like we had a cubic equation, 3, then we should be looking for 3 solutions under normal circumstances. All right. So in this section, we're going to discuss 4 different ways to solve. All right, so the methods to solve in this section will be the zero factor property, the square root property, completing the square, and the quadratic formula.
Hey, Professor, this is section 1.4, right?
No, 1.5.
1.5. Okay.
1.4 was the complex numbers.
Okay. Thank you.
Mm-hmm. So let's look at the zero factor property. Keyword there, well, two keywords. One is zero and the other is factor. So you're gonna have to lean on your factoring skills in order to be able to use this method. It just says that if AB is equal to 0, all right. All right, so if A times B is equal to 0, then A is equal to 0, B is equal to 0, or both. So the first thing we have to recognize, like I said, is the zero factor property. One side has to be equal to 0 before you can do any type of analyzation. You got to set one side equal to 0. Then the other element of it, it had to be factored. In other words, you have to have two factors, not two factors, whatever the factors are of that expression needs to be expressed in this factor form. So in this example, if I have x plus 5 times x plus 2, this is already factored. It's already factored. X plus 5 times x plus 2. And remember, go back to the form, the property A times B. Here we have x plus 5 times x plus 2. Once it factored like that and it's set equal to 0, what I can do from there is set each piece equal to 0 and solve. And I would just subtract 5 from both sides, subtract 2 from both sides. One solution is x equal to -5, and the other one is equal to x equal to -2. All right. Questions. All right. So if I have 4x squared minus 2x equal to 0, it's not in its factored form, so I do need to factor as much as possible. I want to factor down as much as possible. So when I look at 4x squared minus 2x, what I can do is factor out the GCF of 2x. So what's left is 2x minus 1. So notice when you get into the section, you notice they didn't talk about factoring. So they are expecting you to know how to factor coming into this section. If you have trouble with factoring, you always feel free to shoot me an email. I do believe I have a video already made talking about factoring, or maybe it was a rough one. Anyway, either way, just shoot me an email if you need some reminders or tips on how to do factoring. But this section isn't This course really is set up to go back to factoring, but most definitely I can help anybody out who needs it. So like I said, let me know. But once you factor completely, you can set each piece equal to 0 now. So that's 2x equal to 0, 2x minus 1 equal to 0. Now you can solve by dividing by 2. X is equal to 0 here. Here we'll add 1. Divide by 2. X is equal to 1/2. Those will be your 2 solutions. All right, next one, 2x squared plus 7x plus equal to 4. Here you want to set one side equal to 0. So remember the 0 factor property, so you want to set one side equal to 0. So we'll subtract 4 from both sides. Once you have one side set equal to 0, then you go ahead and factor. Now here, because I have a trinomial, if it's factorable, it should be able to factor into my 2 sets of binomials. And my sign should be plus or minus. All right, so I think it's going to be minus, this is going to be plus. Yep. So our sign is going to be plus or minus. You know that by this back sign. That back sign, if it's subtraction, means your sign should be different. The only factors that I have for 2 is 1 and 2. So that's why I have 1x and 2x. Then I have factors for 4. The choices I have, 1 times 4, 2 times 2. And remember, I'm trying to get 7 in the middle. So what I would do is use 4 here and then 1 here. Reason being is because when if I were to multiply this out, remember factoring is the undoing of multiplication. So if I ever want to check my factorization, I can always multiply back out to see what I get and see if I get the original expression. I will get 2 times 4 here, which will give me 8. And then here that will be -1. So 8 and -1 will give me my +7 in the middle. So that's the thought process behind that. Once you've done factoring, you can go ahead and set each part equal to 0. Add 1 to both sides. That'll be 2x equal to 1. Then divide by 2. X is equal to 1/2. Then in the next one, subtract 4 from both sides. Trying to find a good one. Uh, 13 is minus. X squared minus 13x plus 36 equal to 0. So we already have one side equal to 0. So we're looking to factor now. My back sign is positive this time, so that means the signs of my parentheses are going to be the same. And this minus sign right here lets me know that both of them will be minus. Factors of x squared, x times x. Now for 36, I have plenty of options. I have 1 times 36, 2 times, put a 2, hold on. 2 times 18. 3 times 12, 4 times 9. And I want to get 13. I have the same sign, so they have to add together to give me 13. So I'll use the 9 and the 4. So using a negative 4 and a negative 9, I will get negative 13 in the middle. From there, I can set each part equal to 0. Add 4 to both sides, x equal to 4. Add 9 to both sides, x equal to 9. All right. Let's do at least one more, and then we'll look to close out. Next class, we'll start with the square root property. So we have 9x squared plus 9x equal to negative 2. We want to set one side equal to 0. So we'll add 2 to both sides. All right. We have our trinomial. So we set up our parentheses. This back sign is positive, so that means both of my signs should be the same. And then this sign tells me which one to use. So both of my signs should be positive. My choices for 2 is just 1 times 2. So there's really no options there, just 1 and 2. Factors of 9, 1 times 9, 3 times 3. So remember, your goal is to get 9 in the middle. So what I would do is use 3x times 3x in order to get that 9x squared. And once again, don't forget, you can always check it if you're not sure. 3x times 3x is 9x squared. 3x times 2 is 6x. 1 times 3x is 3x. And 1 times 2 is 2. And notice I get 9x in the middle after I add my like terms. So that's what we're talking about, checking out your factorization and making sure that it actually is the correct factorization. So once you've done that, that's 3x plus 1 times 3x plus 2 equal to 0. Set each part equal to 0. Subtract 1 from both sides. That's 3x equal to negative 1. Divide by 3. X is equal to negative 1/3. Subtract 2 from both sides. X is equal to negative 2. Divide by 3. X is equal to negative 2/3. All right. Questions on anything I've written? Anything we talked about today? All right. So, as with everything, and always try this stuff out. Some questions aren't generated till you actually try it out. See if you get stuck on anything. If you do, feel free to shoot me an email. Or if not, you can always wait till next class and we can discuss it during class time. Once again, Monday we are off. I will shoot an email reminder of that. So if everybody's good, I will see you on Wednesday. So have a good one. I see somebody in the chat. Do we have to do the concept quizzes? Is that coming on the test? There should not be any quizzes. I'll take a look to see if anything's up there, but it should not be any quizzes there. All you should have are your homework, pre-test, and tests. Homework, review tests, and tests that are in your assignments. And review tests are not mandatory. All right, not a problem at all. All right. All right, so I will see you all on Wednesday. Have a good one.